Number 2. So I'm going to pick blue. So we're looking at this one right here. So right now we're only dealing with vertical forces. So I'm right away just going to cross off that one force to the right. That's going to make the object move to the right, but it's not going to make it move up and down. And the object's not moving up and down. It's actually either at rest on a table or sliding across the table or some type of surface. So we're going to ask for 2 things. First, we're going to need to find the mass, and we're going to need to find the normal force. Those are 2 things we're looking for. I'm going to start with the mass first. Here is mass. Mass is the weight divided by acceleration due to gravity. If I look on my diagram, I have the weight right there. So it's going to become mass is equal to my weight divided by acceleration due to gravity. Now this is where that whole negative corundum problem, let's say problem, it's easier, falls in. Do I make them negative or positive? Well, if I make weight negative, then acceleration is negative because they're both heading towards the ground. That's the direction the object accelerates, and that's the direction the weight is pulled. So I forgot my newtons. I'm just going to apply it there. But the nice thing is they cancel out anyways. So even if I do that step, it doesn't affect it. So then I'm going to grab a calculator. I have one down here already been using. I'm going to clear my last entry, and I'm going to put 4116 divided by 9.8. I get 420. So the mass of the object is 420 kilograms. The Newton divided by a meter per second squared is a kilogram. Mass can never be negative. Let's make a sum. All right, so the next thing I'm going to do is solve for my normal force. And I have 1 force down, that's my weight. I have 1 force up, 200 newtons, and I have a normal force. Normal force is the support force. How much of the weight do I have to support? Do I have to support all the weight? Do I have to support some of the weight? Or do I have to support more weight? And that's going to depend on which way those other forces are applying. Are they being pushed down or lifted up? This one's being lifted up. So maybe someone's in the process of picking it up from the ground. Maybe it has a hot air balloon or a helium balloon attached to it or a rope, and it's starting to be lifted. So the table, the floor, whatever surface it's on, is not holding the whole thing. So mathematically, let's get back to the math. I'm going to have my force ups. So I have 2 going up, 2 errors. I have normal force and my force applied. And then I have 1 force going down. That's my weight, pointed to the downward direction. And since I'm already using this side as down, down already implies it's negative. I don't have to worry about the negative when I do the math here. So my normal force, I'm going to leave that red just to show up, plus my applied force. Again, that's 200 newtons. That's a 0 there. And I'm just making it worse. 200 newtons equals 4116 newtons. So I need to get the normal force by itself. That means subtract 200 from both sides. So I subtract 200 from the left, it goes away. I subtract 200 from the right, that becomes 4. Oops. Get rid of the 4. It becomes 3916 newtons. I was trying to do that math in my head, missed that step. 3916 newtons is my answer.